Welcome to Homework Lib.
Okay, so in this problem we have a particle inside a three-dimensional box, cubical box. We know that the particle is in the ground state, which means nx, ny, nz equals 1, and therefore, because of that, we also know the solution for the wave function of this particle. Okay, so the solution for the wave function is basically let me see. We have the sine pi xl sine pi yl sine pi zl. All this with, okay, yeah, that's the solution. All the multiplication of the three signs in here. This is the wave function, and the probability is what we must calculate here. So in first item of this problem, we have to calculate the probability of finding the particle in a specific interval. So how we calculate the probability? So the probability P is described by the integral from minus infinity to infinity of the absolute value square of the wave function integrated in the axis. Okay, so therefore we can say that the probability in first item, let's put here item A, this is the first part of the problem, is going to be 2 divided by L cubics. So this is the normalization constant that multiplies the integral from 0 to L half, L divided by 2, sine square pi x L, this is an x, dx, times the integral from 0 to L sine square pi y L dy, and the integral from 0 to L of sine square pi zl dz. So this is the integral we must do. As we can see, uh, all three integrals are the same. The only thing that changes is the interval. The interval in x goes from 0 to half of L, and the integral of y and z goes from 0 to L, the entire size of the box. So let's begin with the standard solution without specifying the intervals. So we have sine square of pi x L dx and the integral here. Okay, so this solution, the standard solution, is going to be, first of all, we use a trigonometric relation and change the sign for 1 minus cosine of 2 pi x L divided by 2 dx, and the solution for this integral here is going to be x divided by 2 minus sine 2 pi x L that multiplies L divided by 4 pi. So this is the standard solution, and we just need to put here the two intervals, 0 to L and 0 to L divided by 2. In this way, we can calculate the two solutions. So without specifying yet the interval, let's put here uh, the first interval goes from 0 to y, which is also equals z, that goes from L. Okay, so this solution is going to be just L divided by 2. And the second integral, we go from 0 to x to L divided by 2. And this one has a solution of L divided by 4. Okay, knowing this, we just need to multiply all the solutions and we have the probability. So the probability is going to be 2 divided by L cubics that multiplies L to the 4 and L divided by 2 square. Multiplying this, we find out the probability is 0.5. So this is the probability of finding the particle in this volume here. And this is item A. Now, we have to repeat the calculation in item B of finding the probability of the particle can be found in a different interval. So let's put here a division. So this is the first answer in red. Now let's move on for item B, which is to find the probability of the same particle, the same energy state, but in a different interval. So the solution for the integral is going to be the same, since we are in the same energy state. The only thing that changes is the interval. Now we have x divided by 2 minus sine of 2 pi xl, L for pi, and the interval goes from L half to L divided by 4. Okay? So applying this interval here, we discover that this is equal L divided by 8 plus L divided by 4 pi. Therefore, the solution will be the same, since the only range that we change is the x. So let's see, the probability is going to be 2 divided by L cubics. This is also the normalization. L divided by 2, which is the solution for both y and z, and the solution for dx, which is L8 plus L4 pi. Okay, calculating this, we discovered that the probability is 0.409. Now we have the last question of this problem, which is to compare our results to the example 41.1, which is the probability of finding a particle in the region, let's put here, in the region 0, the 0 x L to the 4, L divided by 4. So think about this. Example 41.1, we saw the probability of finding a particle in this interval here equal 0.091. Okay? If we look to the solution we just calculated, with the solution of the example, and sum, so 0.091 plus 0.409, this is basically 0.5, which is precisely equal to the solution of the first item, which is the probability of finding the particle in half of the box. Okay, we calculated for the same y and z, but for half of the axis x. Okay, so half of the box. and precisely the same probability. So we can, this explains to us, this shows to us that we can add probabilities. So the probability of finding a particle in the first quarter plus the second quarter should be equal to the probability of finding the particle in the first half of the box. Okay? So that's the final answer to this problem. Thanks for watching.